Hi.
Hello, Haripriya. Today we'll start new chapter, heat and mass transfer, right?
Yes.
Kanishka will be joining. Okay. So now see, before starting heat and mass transfer, you need to learn about the temperature scale. Actually, it's known by the other name as thermal properties of matter. Now, first you need to know few means what are all different scales that are being used for measuring of temperature. Few you may be knowing. First is a Celsius scale, that's degree Celsius. Second is Fahrenheit. This also you may be knowing, represented by F. Third one is Reaumur. This you may not be knowing, presented as Ra. Next is Rankine. This also may be new. R. This you may be knowing, Kelvin scale. Usually in our calculation, we use this, and this. This Reaumur and Rankine are actually new to us. And don't worry, they are actually not asked much in examination also, but you should know how they are related. I'll give you a short formula, means how to convert one scale of temperature to other scale of temperature. That C by 5 is equal to F minus 32 by 9 is equal to K minus 273 by F is equal to R by 4 Ra minus 460 by 10.6. Actually, I am having doubt in one relation. Just wait. Hmm. The problem here is this one. Now everything is correct. Suppose, for example, I have given you the temperature I have given is 100 degrees Celsius. I have asked, this formula is actually important to you to convert to various different scales. Suppose for example, I have given you the temperature in degrees Celsius is 100. Now I want Fahrenheit temperature, so F will be 32 plus 9 by 5 into C. So 32 plus 9 by 5 into 100. So 32 plus 9 into 20. 180 plus 32. 212 degree Fahrenheit. This is how we convert. This is one example of converting 100 degrees Celsius, that's given in C, degree Celsius to Fahrenheit. Okay. If I want Rankine, so 100 by 5 into 4, 160. Like that you'll do. Okay, na, easy?
So, like, what's the least value, like the melting point and boiling point of water in Rankine and Racine scale?
Rankine and Newman. You can calculate it, na? If it is 0 degrees Celsius, it will be, for Rankine also, it will be 0 only, lowest one. 100 means it will be 160.
No, sir, it will be 80, I guess. Yeah, 80.
100 degrees Celsius we are talking, na? 80.
Yeah.
80, sorry.
It's like instead of remembering it like this, we could remember it like the value to be uh, to find minus the melting point by boiling point minus melting point.
Acha. Acha, that way. That way also I am going to tell you. But that's different scale. That depends on the scale to scale. But for that, actually, you must know the lower fixed point and the highest fixed point, upper fixed point and the lower fixed point for each. Means for Fahrenheit also, for Kelvin also, for Rankine also, for Reaumur also. For each, you should know this one. Unless it is given to you, unless unless you remember them, this you can use this formula. If you remember the lower fixed point and the upper fixed point of every scale, you can use that one. The formula that you are telling is, wait, I'll write. Let me write this only, you are telling now. X minus LFP by UFP minus LFP, X1 minus LFP by UFP minus LFP. Like this is for scale 1, this is for scale 2. Suppose they have asked, scale 1 means it's in degrees Celsius. Suppose the given temperature is 20 degrees Celsius. Okay, you have to convert it into another scale whose lower fixed point and the upper fixed point you know. Means like lower fixed point is what? The freezing point. Yes, and the upper fixed point is the boiling point. for each scale. Now, for example, what I was giving, for the example is 20 degrees Celsius. Now, for degree Celsius scale, they have given the lower fixed point, we know it is 0 degrees Celsius, and the upper fixed point is 100 degrees Celsius. It's 0. So to convert into any other scale for which you know the lower fixed point and the upper fixed point, suppose for the new scale, you have the lower fixed point as 3 degrees Celsius, upper fixed point as 120. So now according to this scale too, we do not know whether it is in degrees Celsius or some other scale, but according to this new scale, you'll get the value of the temperature. The value of x1 that you will calculate will give you the 20 degrees Celsius will correspond to what temperature on the new scale. Understood? This only you were telling, na? Hey, Priya?
Yes, sir, I was telling about this.
It's up to you. You can use any formula. Either you can use this method or that method. You're
It's
comfort.
like you get confused with numbers, sir.
There, na? In this one, but in this one you can use actually when problems they give, na. I'll give you the problems. When they give you the problems, na, this is mostly used. But sometimes they actually do not give you the lower fixed point and the upper fixed point for every scale. When they do not give at
Actually,
that
this
time,
is useful in finding the faulty thermometers.
faulty thermometer it is useful. You can compare. Means if the thermometer 0 degrees Celsius is giving something else, the boiling point is giving something else, then according to that thermometer or that you can find out the value with the according to the for accurate thermometer you're getting some temperature, then for faulty thermometer what you will get, or the faulty thermometer reading is something else, then for accurate one what you will get, you can calculate. Actually this is not limited to this formula only. What Kanishka, you understood this one? Temperature comparison
Yes,
on
sir.
difference. Okay, yes. Now this is actually this formula is not limited to this one. You can extend this formula to lower fixed x minus x LFP by UFP minus LFP is equal to pressure also P minus P naught by P100 minus P naught, or V minus V naught by V100 minus V naught, where P naught represents the lower fixed point pressure and P100 is the upper fixed point pressure. Similarly, V naught represents the lower fixed point volume, and V100 represents the upper fixed point volume. Okay, understood? Now let me give you some question. Attempt it.
So 98.
98. Wait. Hmm. 98 is the answer. Anushka, do you want me to solve it?
No, sir.
Done. Because see,
Yes,
it's
sir.
in the old scale, the lower fixed point was 0 degrees Celsius. Upper fixed point was 100 degrees Celsius. Now in the new scale, they have given lower fixed point is 20, upper fixed point is 150. So the temperature they're asking, in this, the temperature they are asking is given is 60 degrees Celsius. Now for this one, they are asking what is the temperature. So you'll use this formula 60 minus 0 by 100 minus 0 is equal to x1 minus 20 by 150 minus 20. 60 by 100 is equal to x1 minus 20 by 130. 78 plus 20 is equal to x1. X1 will be 98 degrees Celsius. Solved. Now let me give you one more question. I just
So it is option B, 16 by
Hmm.
25 100.
Correct. It's option B. Actually, not difficult. It's easy only. See, because the normal scale you have lower fixed point as 0 degrees Celsius and upper fixed point as 100 degrees Celsius. Temperature of this they are asking. Acha, हाँ, see, now the pressure relation you have to use. Thermometer is in steam at a pressure of 1 atmosphere. It registered -3 and the bulb of thermometer is in pure melting ice. Okay. So P0 for new scale, P0 is -3 mm and P100 is 22 mm. Acha, now the pressure they have given pressure registered is 13 mm. So you can use this relation P minus P naught by P100 minus P naught. So you will get this one as x minus 0 by 100 minus 0 is equal to 13 minus of -3 divided by 22 minus of -3. So x by 100 is equal to 16 by 25. Oh, it was very easy. X is equal to 16 by 25 into 100. So if Kanishka has not got the answer, she can see here. But it was easy only. The question I gave this question to you because the comparison with pressure is given in this. Rest all is easy. Rest all comparison you can do. It's not much difficult. You will be able to do it easily. Not difficult. No difficulty. You have to use only this comparison formula that I have given. These two, this one and above one, and this one. Now let me move on. The next part is thermal expansion. See what they say. Actually, you must have observed. Actually, it is very difficult to observe in our daily life. Whenever, because why it is difficult? Why it is difficult? Because in our daily life, na, the expansion due to the temperature change actually takes place very slow, so slow that it's difficult to observe unless you increase the temperature by a significant amount. You will not be able to see the expansion then and there only. So what they say, whenever we increase the temperature of a body, suppose we have a body whose length is L. At this point, say L naught, at this point we are actually fixing the area. Means it should have some cross-sectional area like this, but we are fixing the area, means the area is not changing for this. But in reality, area also changes. But what we are thinking, that area is not changing here. When we are raising the temperature from T1 to T2, where T2 is greater than T1, the length the length of the bar actually increases. It becomes L. So according to this theory of thermal expansion, linear expansion, what they said, The increase in length L because of rise of temperature L is given as L naught into 1 plus alpha delta T, where delta T is T2 minus T1. And where alpha is what? L naught and L, you know. L naught is the original length, L is the increase in new length, and delta T is the rising temperature, alpha is the coefficient of thermal expansion. Actually, coefficient of linear expansion. Right? Now, sometimes they actually ask you what is the increase in length, delta L. So delta L is actually what? L minus L naught. And using this formula, actually you can use L is L naught plus L naught alpha delta T minus L naught. Cancel it out. So increase in length has become L naught alpha delta T. This is the increase in length formula, which actually it's not difficult, but it's better you remember this one, because if you remember this, sometimes the problems solving becomes easy. Now, when we are talking about problem solving, one more thing also I'll tell you. You must have heard about the term strain. Do you know it, Haripriya? So what is strain?
Yes, sir.
What is it?
It's the change in length produced due the change
Increase
in
in
dimension produced in,
actually there's strain of different types, but when you are talking about linear strain, it's increase in length, change in length per unit by original length. So delta L naught L by L naught. So here delta L is L naught alpha delta T. Original is L naught. So the strain becomes alpha delta T. Now you must have also heard about Young modulus, which is stress by strain. So from this relation, we can actually write stress is equal to Young modulus into strain. So you can write the relation Y alpha delta T is the stress. And what do you know about stress?
the restoring force developed
Per unit area.
per unit area.
They must have taught you in schools. Stress is actually when you apply some force, no? The opposite force that the body applies. It's the restoring force, which tries to restore it. That restoring force acting per unit area is known as the stress. Or you can write force per unit area. So stress we have actually found. Actually, the formulas that I'm boxing, na, these formulas you will use when you are solving problems. Actually, the good quality of problems when they create, na, they actually make use of these formulas. So the force which is generated is equal to stress into area, which will be equal to Y A alpha delta T, where area is A, and let me write Y also, Young modulus. Kanisha, you have the idea of this one now? The somewhat idea of this Young modulus
Yes,
stress
sir.
strength.
Yes, sir.
Okay. Okay. So the force that is generated, see what I am trying to stress upon, na? What I am trying to tell you, whenever there is an increase in length, whenever there is a rise in temperature, there is increase in length, and that increase in length is given by L naught alpha delta t. Now, because of this, the strain which is produced in the body is alpha delta t. That formula also you'll use. The stress is Y alpha delta t and the force is Ya alpha delta t. This thing. Now, with this, let me quickly tell you about the areal expansion and volume expansion also, and then we'll solve some problem. What is areal expansion? Now, in the above case, I have actually assumed there is no increase in the area. But now here, I'll increase the area of the body. Let's say initially the length was x and the breadth was y. It's looking like square, but you believe it is rectangle. Now initial area A naught I can write x into y. Let's say I have raised the temperature delta T, T2 minus T1, where T2 is greater than T1. So both length and breadth will increase. Now the new length, say it has become x1, new breadth has become y1. So x1 will be x into 1 plus alpha delta T. Y1 will be y into 1 plus alpha delta T. Now the new area has become what? X1 and y1, which is xy into 1 plus alpha delta T whole square. Correct? Now comes the thing. A new is equal to initial area A naught into 1 plus alpha delta T. Now, here, usually what we do, Haripriya, what you are doing? What Haripriya is doing? Actually, I think, and Haripriya, what you are doing? You are going and coming. Is it net problem?
No, sir, my laptop actually took automatic updation. So I
Okay.
just got logged out and then I joined in my
Hmm.
mobile search.
Hmm. You have to regularly update it. There is no, you cannot ignore it. Sometimes 2 or 3 times you'll ignore it, and again there will be a point where it won't allow you to start, or it won't allow you to shut down unless you update it. Here alpha is actually very small. So what happens, this alpha delta t whole square terms, square or higher powers become 0. So we actually use this binomial expansion 1 plus x whole power n is approximately equal to 1 plus nx. So this becomes a naught into 1 plus 2 alpha delta t. So this becomes our new formula. Whenever there is an areal expansion going on, the usually they write a nu is equal to a naught into 1 plus beta delta t. This is the formula, but through derivation, we have actually found out this beta is actually equal to 2 alpha. Where beta is what? Beta is supposed to be coefficient of areal expansion. Clear up to here?
Yes, sir.
So similarly, can you tell me what should be the formula for volume expansion? Take a case of a cube. It's up to you if you want to take each side as equal or each side as different. Doesn't matter. X, Y, take this as Z. It's given V1 is equal to V0 into 1 plus gamma delta T. You have to find where delta T is. T2 minus T1. T2 is greater than T1. You have to find out the value of gamma. V obviously will be equal to X, Y, Z. You have to find out the value of gamma. Like I have done for the above case, for the area case.
So you'll get gamma is equal to 3R.
Very good. So V1 will be equal to V0 into 1 plus 3 alpha delta T. Again, see, remember, we are actually using here the binomial expansion 1 plus x whole power n is equal to 1 plus nx when higher powers are neglected. Why we are neglecting higher powers? Because the value of alpha that you will see now, actually it's very less, 10 power minus something. So we can neglect the higher powers of alpha T. Now, when this is compared, V1 is equal to V0 into 1 plus gamma delta T, there gamma will become equal to 3 alpha. Now there is a relation again with coefficient of, where gamma is what? Coefficient of volume expansion. So the relation alpha is to beta is to gamma is equal to alpha is to 2 alpha is to 3 alpha, which is 1 is to 2 is to 3. Relation between alpha, beta and gamma is this. Now I'll give you a question. Try solving this. See, see the value of alpha. Alpha of iron 10 power minus 6. Alpha of copper 10 power minus 6. How low it is. That's why we actually neglect. Now try to study this question and then try to solve it by yourself. Now we have to solve it. What happened, Haripriya? Did you get the answer?
Sir, I got it till 110/6. I just didn't do the calculation.
It was it was actually easy. 18.3 and 20 means you got the answer. What about Kanishka? Kanishka answer आ गया?
Yes, sir.
Okay, very good. Now try to solve this question.
Sir, option A.
Hmm. What about you, Kanishka? You got the answer? Just let me solve it quickly. There were two wires. One was of length L1, alpha 1. Other was of length L2, alpha 2. effective temperature coefficient of linear expansion they are asking. Means if we replace this with some rod with linear coefficient of linear expansion alpha naught, then what would be this alpha naught? If we are raising both by temperature delta T. So if we raise the temperature, new length will be L1 dash plus L2 dash, which will be L1 into 1 plus alpha 1 delta T plus L2 into 1 plus alpha 2 delta T. Now in the second case, L1 dash plus L2 dash is equal to L1 plus L2 into 1 plus alpha naught delta T. Now we compare these. L1 plus L2 plus L1 plus L2 into alpha naught delta T is equal to L1 plus L2 plus L1 alpha 1 delta T plus L2 alpha 2 delta T. This you can cancel out. So delta T also you can cancel them. So alpha naught is equal to L1 alpha 1 plus L2 alpha 2 divided by L1 plus L2. Done. In the next class, we'll solve some more questions and then we'll move on to the next topic, that calorimetry and specific heat capacity. Okay, let's end the class then. Bye bye. Good night.
Bye.
Bye.